Okay, so today we are starting our new lesson, which is OSPF, and OSPF stands for Open Shortest Path First. We already know that OSPF comes from the dynamic family, okay, dynamic routing protocol family, and OSPF is an open standard routing protocol. Means we can use OSPF on different routing routers platform on different routers, not only on Cisco. You will find OSPF everywhere nowadays. And OSPF is a link state routing protocol, same opposite of RIP and EIGRP. RIP and EIGRP is a distance vector routing protocol which works on hops. Okay, OSPF use IP port number 89, same like your RIP and EIGRP. RIP works on UDP and port number is 520. EIGRP works with IP and port number is 88. Same here. OSPF use port number 89. OSPF use process ID from like from 1 to 65,535, and like when we talk about process, okay, so EIGRP have also some process. Those EIGRP process is known as EIGRP autonomous system number. RIP doesn't have any process. Like RIP is a single routing protocol. We cannot run multiple routing protocols with like in a single router. So I can show you right now, like see process, or when you see like that means you can run multiple OSPF process with a single router. Okay, and whenever you want to enable route OSPF routing protocols, we have to use process, like okay, process 1, process 2, process 3, and that process will tell you that it tells how many networks and routers are in the same OSPF administrative unit. Means with the single process means how many networks are associated with that single process. Okay, so let me show you here. Okay, so let me show you few processes regarding that how many process you can run in a single router when we are talking about EIGRP, OSPF, and RIP. So let me open one test lab. So if I'm coming here, okay, we have already routers one. Okay. So let me take one router, single router. Start this router and take a console of this router. So when we are here, suppose I want to run here conft router RIP version 2 exit. Okay, if I'm running router RIP, there is no any other options. Okay, so you can run only single RIP process. But if here, if you want here router EIGRP 10, and then you can say here exit router EIGRP 20, exit 30, exit 40, exit. Same like router OSPF process number 1, exit. Okay, why it's failed? Because see, you cannot create OSPF or something like that when you are now, if you do not have any interface, or if you are not including router ID. So no problem, for testing purpose we can say okay, for OSPF1 our router ID is 1.1.1.1, router ID is 1.1.1, and for OSPF process 2 my router ID is 2.2.2.2. So like this, if you are checking now like so, IP protocols, so you can see here that, see, EIGRP10 is running here, EIGRP20 is running here, EIGRP30 is running here, EIGRP40 is running here. Even if you are checking here, see, OSPF process number 1 is there, OSPF process number 2 is there. So what I was saying here, that you can run multiple OSPF process and multiple EIGRP process in a single router. Why? Because they have, like, EIGRP is using autonomous system number and OSPF is using process number. But RIP is a single, okay, that's why we cannot use multiple RIP process in a single router. Or you can say that we cannot use multiple RIP process in a single administrative domain, but we can use multiple processes of EIGRP and OSPF in a single administrative unit or domain. OSPF can establish adjacency with the router connected to the same link using the same area. So whenever you have a domain of OSPF, and in that, when you exchange the database with the neighbor, so those neighbors uh, uh, who are connected in a same area, those neighbors are known as adjacent neighbor, okay, or adjacencies between two routers. So exchanging the database is known as adjacent neighbor. So same here, what is adjacency? Adjacency is the relationship with two routers when they send updates to each other about the network condition, or you can say about the database or about the routing table, and they exchange the database. Okay, now OSPF sends, like, what type of database is there in OSPF? So here is that OSPF send link state advertisement to the neighbor routers, okay, in the same area. So whenever you means like routers are in a same area, so they exchange link state advertisement between neighbors, and on the behalf of LSA, they construct the link state database. Means like, suppose R1 is the neighbor of R2, so R1 will send LSA to R2, and on the behalf of received LSA, R2 will create its own routing table, or you can say own database table. Okay, now, so the information about OSPF area comes in the form of LSA. Means whatever router sends the information regarding networks, regarding the links information, okay, so those comes under LSA update, or you can say LSU, link state update. Okay, now when we talk about that, okay, what are there inside LSA? Okay, so LSA contains the router's local routing topology, means local, all your interface information, and all other routers information uh, working within the same OSPF area. Means all other routers information of the same area. Okay, so maybe if R1 is connected to R2 and R2 is connected to R3, so if R1 is sending some data to R2, so R2 has to forward to R3. Okay, so that's why it's saying that other routers information is also there. It's not only seeing locally, local information is there. Like, if we are coming here, suppose you have here one router. See, if only single two routers are there, right? and in this both router is connected. Okay, this both router is connected. So here this R1 will send its locally information like LSA, and here also uh, this guy will send LSA to him. Okay, LSA, right? But like LSA, and those LSA will be the information of locally connected in networks, right? But I'm saying that if you have R3 here, maybe you have another R3, and here this R3 is connected. Okay, R3 is connected here. So here this R2 will send LSA to R3 LSA. Now what will be there in LSA? So this will be say R2 will say that yes, in this LSA my local connected informations are there, my local networks are there, and as well as R1 router information network information is also there. Then R3 will receive those informations. Okay. Now OSPF LSA database is will be refreshed or in every 30 minutes. Okay, like normally we know that RIP sends periodic update in every 30 seconds, right? EIGRP do not send periodic updates. It sends periodic hello message, but update is not periodic, and hello message is periodic just because of keep alive between neighbors, that whether the neighbor is alive or down. Okay, and like EIGRP sends update only when there is changes. Okay, after first update, when there is any changes. And here in OSPF also do the same thing like EIGRP, but one additional function is there in OSPF, that OSPF says that no problem, I will send you only the updates on like only the changes update, okay, after first time update. But OSPF refresh its database and updates the database in every 30 minutes. That is, like OSPF is different than other routing protocols. So in every 30 minutes they updates their database. Okay. Now OSPF construct link state database. As I told you that OSPF build the its own database, means OSPF router builds its own database on the behalf of received LSA from neighbor. Now OSPF has each area database, like in OSPF each area database should look identical in all of the routers participating in the to that area. Okay, means like uh, when here we are talking about area concept. Okay, so let me describe this area concept, so you will understand why OSPF use area. Suppose we have this, suppose for example this the network what we are getting here, this is your EIGRP network, for example. Okay, this is your EIGRP network. EIGRP, right? So when it has EIGRP network, so in EIGRP network, the routing table of all the routers which is working under EIGRP, it will be same, right? And if you have thousands of networks running inside EIGRP domain or EIGRP administrative domain, so all routers will be managing thousands routing tables, right? So whenever any routes is coming, so all the routers have to process all those thousands routing informations, right? So in this case, what is happening here, depending on the routers, like capacity, maybe this router capacity is different as compared to router 2, right? Or maybe router 2 capacity is different as compared to router 3, but each and every router has to process the same, right? So what will happen, maybe this router won't be able to run the process quickly because of CPU utilization, maybe, right? And the database is also heavy. But in OSPF domain, what is happening here? In OSPF, what is saying that no problem. What we can do, we can divide, like in switching technology, what we used to do, we used to break the large switching broadcast domain to a small broadcast domain, remember, using VLANs. Okay, so like VLAN 10, VLAN 10, 20, 30, 40, 50, like that, right? Okay, so, and they all are connected, and everything is working fine. So each and every switch is operating and saving the bandwidth, no extra uh, broadcast, unnecessary broadcast, you can say, right? So same here in OSPF. What is OSPF saying? That instead of having a large database, okay, we could have small database, like, okay, let me connect like 10 routers in one area, 10 routers in another area, another 10 routers in another area, and in the middle of those routers we could have one router which is working as a border router. So this border router will exchange the database from one area to another area. So they kept area 0 as a border area, okay, and other areas they are working like a separate area. So whenever another, like area 1 wants to communicate to area 2, so both areas should communicate to area 0. So area 0 is working as a transit area, okay, and now the database is separate. So for example, you in EIGRP domain, we have thousands database, right? So here we can divide those 1000 database in 250, 250, 250, like that, right? So this is the benefit in OSPF, and that's why OSPF supports large, uh, large infrastructure routing. Okay, and like area one routing table will be different than area two, but the routers which is working within the area, all routers routing or database should be identical always. Okay, now here once the OSPF routers LSD means link state database have been populated, okay, then OSPF routers will be able to see the map of the area. Okay, means LSD is a link state database, okay, and the link state database is now populated everywhere in the same area on the routers, and from that single router you will see the entire map of your routing database or OSPF administrative domain. Okay, and OSPF uh, runs one algorithm which is known as shortest path algorithm, which is, with that algorithm, OSPF routers define the shortest path from, like, to reach destination. Okay, means after having the database, once they will have database inside the router, and after database they will run SPF in, okay, to calculate best path, and according to that best path they will add those information in the routing table. Now OSPF determine the best path using cost of the link. We'll see how to calculate the cost and how it is working, same like what how we have worked in EIGRP. Okay, and how we will come to know about the cost. So cost is the function of the interface link bandwidth. So whatever like interface you have connected in the router, maybe like you have Ethernet, you have fast Ethernet, you have gig Ethernet. So depending on the interface you will have the cost, and depending on the interface bandwidth you will have the cost. And how cost calculation is there, we will see while practicing it. Now, OSPF attempts to inject best path for each network into a router, okay, IP routing table using RIB. RIB is known as routing information base, means like simply you have to understand that OSPF inject best path, okay, in the routing table with the help of RIB, routing information base. Like OSPF rib is there. Inside rib all the information is there after the shortest path calculation from the database, and after that it will keep in the routing table the best one, but the database will be there. Okay, now OSPF rib is like EIGRP topology, same like. So EIGRP topology will be the entire like entire just like neighbor like informations, like what we can say, how they are connected, the distance, okay, feasible distance, sorry, okay. So the entire feasible distance information, or you can say all feasible distance information, and from that the best feasible distance will be in the routing table, okay, which is known as successor. Okay, so same here also in OSPF, the OSPF rib is working like a EIGRP, and from that it will keep the best routing information or best path to the routing table. So OSPF calculate the best path to the destination network, and it will be injected to OSPF routing table. Same thing. Okay. Okay. Now OSPF has means like OSPF use an administrative distance of 110. This is default administrative distance. OSPF default hello interval is 10 seconds, means in every 10 seconds the OSPF routers generate hello message and send to the neighbors, and this 10 seconds will be used when OSPF router is using LAN link, okay, and the hello timer will be changed when you are using WAN link, like frame relay link, okay, or maybe like some other like we'll see the WAN link, okay. But normally this when you see LAN or WAN link, so LAN has the 10 seconds, and WAN hello is when means your whenever you are using WAN interface, at that time the hello timer will be 30 seconds. Same here in OSPF dead timer, or you can say hold down timer, is 40 seconds when you are using LAN link, and 120 seconds when you are using WAN links, okay. Now OSPF IPv4 version is like, see, OSPF is routing protocol. When you are configuring OSPF using IPv4 IP, or inside IPv4 administrative domain, so at that time OSPF version will be version 2, and when you are using OSPF using IPv6, at that time it will be OSPF version 3. Now OSPF use two multicast addresses. Like normally other routing protocols they use single multicast address, but here OSPF use two multicast address, which is 224005 and 224006. Now 224005s are used for sending hello message, or you can say used by all routers for communications, okay. Like we'll see what is DR, okay, like designated router, backup designated router, we'll see this one. But for now you have to understand that whenever all routers wants to send information to each other, so they will be using this 224005. But when other routers like non-DR routers, or when other routers want to send update, okay, so at that time they will be using 224006. And in some condition the OSPF routers use 224005 and 224006, but in some condition OSPF router use only 224005, no 6. So we'll see all these things. Now you can say, but okay, but hello message between neighbors will be always sent via 224005. And how to check all those things, okay, it is here. So it will be better to show you this one before moving into practical. You know the OSPF configuration, okay, OSPF routing. So let me open one lab here. Let's make one OSPF test lab. OSPF test lab. In this, what we are going to do, we are going to collect two routers here. So if we are connecting these routers through Ethernet, okay, so here let's use normal 12.1.1.0/30, and each router will have loopbacks. So here it has loopback 1/32, and router 2 will have same loopback 1 2.2.2 2.2.2. Okay. And here we are running OSPF area 1 or 0, no problem. So enable it. So here we are, both router interface is E0/0. Start all the devices. Okay, so if we are coming here, let's take console of all the devices. Router 1, configure the IP addresses. Conft interface E0/0. IP address is 12.1.1.1. No shut, and then interface loopback 1. IP address is 1.1.1.1. Save it. Come to router 2. Config interface is 0/0. IP address is 12.1.1.2. 252. No shut, and then interface loopback 1. IP address 2.2.2.2. And okay, now we are coming here on router 1. Conft router OSPF1 network 0000, or network whatever is there you can advertise, like 12.1.1.0, and wildcard mask is this, and then area 0. Again here you can 1.1.1.1 wildcard mask area 0. Exit. Now come here, you can save as well. Now if you're coming to R2, router OSPF1 network 12.1.1.2 or 0 3 area 0. Then again you can configure here 2.2.2.2 and then exit. Now you will find that membership will come up. Okay, membership has came up. Okay, so now we wanted to verify your like the OSPF router multicast addresses, right? So as I told you that OSPF use two multicast addresses 224005 and 224006. Now in which condition OSPF use 224005 and in which condition OSPF use 224006? Now, so first, so IP interface E0/0. E0/0. So you can see here OSPF router is using 224005 and 224006 both. This one is also multicast address, but this multicast address is multicast DNS address. Okay. If you want, I can show you, because this is not a part of this OSPF, but I can show you that why OSPF use this IP address. Multicast address use. Okay, so this address is, I told you, it's a multicast DNS address. It is reserved for multicast DNS. Okay, and 224005 and 224006 is used for OSPF process. Okay, that is for multicast DNS. So we are talking about 224005 and 224006. So here is saying that this interface is working with OSPF, and this interface is the part of, means it's, this interface has joined a group of two IP multicast, which is 224005 and 224006. Let's come here to this R2 as well, and if you can run this command, so IP interface is 0 by 0. So this one has also joined the same multicast address, right? Okay. Now, in which condition 224005 and in 224006 will be used? Whenever you are using Ethernet family, okay, multicast, okay, like Ethernet link, and in Ethernet you can have Ethernet, fast Ethernet or Giga Ethernet. Okay, in that case you will have this both IP address, means your OSPF will use 224005 and 224006 both IP. Okay, now you know sometime we use routers with serial link, right? So let's delete this one and now use this serial link, serial 0 by 0 to serial 0 by 0. Okay, connected serial 0 by 0 to serial 0 by 0. Now what we'll do, we'll remove that IP address which was there on the E0 by 0. So we can come here, interface E0 by 0, no IP address, then we'll come here interface serial 2 by 0, IP address 12.1.1.1, no shut. And now if you're coming R2, quantity interface is 0 by 0, no IP address, then interface serial 2 by 0, IP address 12.1.1.2, no shut, and neighborship will come up. Just wait, location neighborship came up, and now let's check, let's verify with that. So interface, now here we'll check serial 2 by 0. Now here you can see that your interface which is working with OSPF, it has joined only 224005, okay, no 224006. So when the topology change, and now when the topology change, you are using which type of uh, link? It's a serial link, right? Serial link. So in this case you have seen that your router, or you can say your OSPF router interface has joined this multicast address. Okay, so we'll see this whole thing dr. Okay, dr, what is dr, what is non-dr, what is bdr. Okay, so we have verified. Okay, now OSPF use process ID from 1 to 65,535, and whenever you want to verify the OSPF process, means how much it can support, so we can come here and we, like if you are coming here router OSPF and put question mark, you can see here means how many process ID can be supported. Okay, same like you remember EIGRP autonomous system number. So here it is showing autonomous system number, and here it is showing process ID, but it's the same thing. Okay, it's okay. Now let's come here. Now OSPF process. So OSPF process ID. So the process ID. What is OSPF process ID? So let's understand more about process ID. So the process ID is the ID of the OSPF processes to which the interface belongs. Means if you can come and see here, like how many interface is running under the same process ID. Okay, so if you will check here, serial 2 by 0, sorry, serial 2 by 0. Okay, sorry, so IP OSPF. Okay, you can see here, uh, this is OSPF process ID 1 is running. Okay, process ID in OSPF summary interface is 0 by sorry, serial 2 by 0, serial 2 by 0. So you can see here this interface, okay, which IP is this one, is running inside OSPF. Okay, area 0 and cost is 64, and see, this is the process ID, means this interface is working under OSPF process ID 1. Okay, maybe I have some routers here. Let me add one more router. Okay, and with this, router 3 is connected with router 2 via E0 by 0. Okay, and here you are using 13 IP, something like that. Okay, 13.0/30. Start and take a console. So first I'll come to R1 and conf interface E0 by 0, IP address 13.1.1.1. no shut, and then exit, and then come here to R3 conf interface E0 by 0, IP address 13.2, no shut, and then router OSPF 2 network 13.1.1.0, and then area 0. Exit. If you want, you can see, you can type here, so IP OSPF interface E0 by 0. Okay, and if you're coming here, our router OSPF 2 network 13.1.1.0 3 area 0. You'll see neighborship will come up, just wait, and then now you check interface. So here you have two interface which is participating under OSPF processes. So E0 by 0, right? E0 by 0 is working under process 2. Okay, and your serial 2 by 0 is working under process 1. Okay, so you have multiple processes. Okay, now here is saying that the process ID is the local to the router, and two OSPF neighboring router can have different or same OSPF process ID. So if I'm coming here, and you will see that we have created same process ID, right, between R1 and R2 neighborship. You will check here also, sorry, R1 and R3 neighborship, same here also. But I'll say no, let me change it. So I'll come here in router OSPF 3 maybe I'm using 3. Okay, or first let me remove that one. No exit. Let me remove that one. No, and then let me create OSPF 20, and then network 13.0.0 3 area 0. Okay, neighborship came up, and for you is means for router 3, process ID is 20 and their neighborship, if you check here, so IP OSPF neighbor. Okay, see, they are neighbor. Okay, and process ID is different, so he's saying that it could be same or it can be different also, there is no any problem. Okay, because the process ID is the local to the router. Now here you have one question, and I think we have done this one through practical. Does OSPF process ID have to match? Yes, we have done in practical, and we have seen that it could be same or it can be different also, no problem, because the process ID is local to the router. So same here, the OSPF process ID is a numeric value local to the router. It does not have to match process ID with other routers in OSPF domain. They are locally significant and only like means why they have process ID, just boundary between two processes. Okay, so why we create multiple OSPF process? Okay, just to separate your routing updates, and okay, and whenever I want to get the information regarding single process, right? So if you check here the routing table of R1 routing table here, so IP route. Okay, see, routing table, there is no any problem in the routing table. If you are coming on R3, so IP route, see, no problem. Just to separate the process, like suppose I want to, maybe like what will happen, why we use multiple processes, maybe I have two branch 1 and branch 2. Okay, this is headquarter, so this is your headquarter, and headquarters is connected with branch 2 and branch 3, like that. Now if you run everything under single OSPF process, and maybe you want to break this relationship, now you want to delete this neighborship or delete this branch, so what you have to do? So you have to alter your or you have to change something in your routing table, sorry, your OSPF running routing. You have to say no routing neighbor with this one. Okay, and now when you have like, if you have multiple processes running, so what you can say, you can simply come and say no OSPF process 3, no OSPF process 2. That's it, and still you have this process and you have this neighbor right now. Okay, okay, so OSPF process ID range we have already checked, which is from 1 to 65,535. And how to check these all process ID? We have multiple options to check that how many processes are running. Okay, so if you run show IP protocol or show IP OSPF, you will get these ones. Okay, so if I'm coming here on router 1, if I'm typing here show IP protocol, you'll see that yes, OSPF 1 and OSPF 2 is running here. Okay, and so IP OSPF, in that also you can get yes. We have two processes running, you can see here. Okay, now okay, one more thing regarding okay, no problem, later. Okay, now types of messages in OSPF. Okay, so we have multiple types of messages in OSPF. We have 5 types of OSPF messages, which is known as type 1, type 2, type 3, type 4, type 5, like that. Okay, but what message is there in type 1? So hello message is known as type 1, database description message means the update message, you can say database update message, or database description is known as type 2 message. Okay, and type 3 is known as link state request, LSR. Okay, and LSU is link state update, is type 4, and type 5 is LSAC. Okay, now understand what is there in hello message. See, hello message is used to discover the neighbor. So whenever routers want discover the neighbor, so for discovering the neighbor they send hello message. And hello message is also used for keep alive messages between the neighbors. They send in every 10 seconds to first to make neighborship, and after once the neighborship is done, then they check the neighbor status where the neighbor is connected up or down. Okay, hello message will be sent always using multicast, which is 224.0.0.5, and hello can be sent via unicast also, but the condition is if you have configured your neighbor statically, not dynamically. Okay, now this DBD, database description packet or message, you can say, it is used to elect master and slave. Okay, so this master and slave will understand, like, see, it same like master and slave, like there will be one boss and all the routers like same, like root switch. So here also you have one master, in that each slave will be connected to master and they will be exchanging the database with master, and master will be responsible to exchange the database with the slaves. Okay, so the master routers are known as DR router. Okay, and the slave routers are known as non-DR routers. Okay, designated router and non-designated routers. So here elects the master and slave, determine the initial sequence number of database, and you can say database exchange. Okay, and here you can say LSDB contents, means like LSDB is link state database, contents using LSA header between routers during the database exchange process. So whenever database exchange process will be there, so the first, before moving to database exchange, they first elect who will be the master and who will be the slave. After that they will determine who will begin the exchange, who will start the exchange. LSR is the link state request. In that, what is happening, like whenever routers neighbor routers is missing to have some network information is missing, or maybe like they have partial information but they do not have full information, or maybe any link is down or something is happening, so they will send a request to the neighbor routers that please, I'm missing the information or the route of this network, please can you provide me the full information so I can reach to that destination. Okay, so request for a specific ls record means link state record. Okay, so routers will generate LSR, and the routers who will provide the updates regarding the LSR, those messages will be known as okay, link state update. And once you will receive LSU, means once means like router will receive LSU, so the routers acknowledge with LSAC that yes, the receipt of acknowledgement that yes, I have received your update, thank you. Okay, now when we say that okay, when the router sent hello packet to the neighbor, so what informations are there in the hello packet and how the header look like? Okay, what are the informations are there? Okay, so each on uh, information is there, and what is the detail, what is the meaning of those information, so we'll come to know each and everything here. Okay, so let me show you all the hello packet contents. So for that hello packet content, what we can come here, right click and start capture. Okay, so it started here Wireshark, and like this is your router 1 sending hello message to router 2. So just open this hello message. Okay, and let me explain you all these hello messages. So the content of the hello message is like, see, the version, right? So here is OSPF version 2 means we are using OSPF v4 IPv4, that's why version 2. Okay, message type is this one, type 1 is okay, it's a hello packet. Packet length, okay. Now OSPF source router ID. Source router means who has generated this hello message, the router ID of that router, okay. And we'll come to know what is the router ID later. Now this router means router 1 belongs to which area, whether it belongs to area 0, area 1, area 2 or what, okay. But you say that the area ID what you have given, you gave area 0, otherwise it is coming as a area 0000. So whatever area we assign normally with decimal number, okay, and it will be converted to IP segments, okay, in the IP format. Like suppose if you'll assign something like 10, so it will come as a 000010. But if you assign something like 256, okay, so in IP address there is no 256. So what they will say, okay, 255, and so 255 is what, two, okay. If it is normally, if I'm saying, okay, let me show you 255 first. So if I'm coming here, OSPF router 1, and come here conf2 router OSPF process 1 network 0000000 area 256, for example, like that. And now let me come here to have another OSPF message, hello message, hello message. And now if you're checking here, okay, not this one. Do I have this hello packet, new hello packet? Right click, start Warsack. Okay, so we are working with the new hello packet. Open this new hello packet after changing the router ID. Wait, come again, what I have given, area 256, area 256 I'm saying. Okay, no problem, but I can say no router OSPF 1, no router OSPF, okay, then router OSPF 1 network 0000 all, and then area 256, okay. Here also come to router 2 and conf t router OSPF 1 OSPF 1 say network 0000 0.0 area 256, okay. Now let's have the new hello packet and see. Okay, so new hello packet, uh, new hello packet, this one is new hello packet. So hello, let's open this hello packet. So in this hello packet we can see that, see, now the router ID is 0010. Okay, so 0 means what? When you have this 1, okay, 1 means you have already completed 255. This 0 means 255 and 1 means 256. Okay, that's why it is like that. So okay, sorry, we were talking about hello packet information. Okay, so after area ID, you have some checksum. Okay, checksum means in every messages there will be checksum. Okay, and checksum is correct. Authentication data. Okay, so there are two type of authentication type and authentication data. So authentication type means clear text and md5. So whether OSPF using clear text or md5, so here will be the information of the type and here will be the authentication. Okay, and why there is nothing? Because there is no authentication between routers. Now network mask means they are connected on which network subnet. Hello time sec. Okay, hello and dead timing. Okay, so hello is 10 seconds. Now the router link priority. Okay, and by default all the link priority is 1. Okay, if you will check here, so so IP OSPF neighbor. Okay, so you can see here. Okay, this is serial, that's why priority. Okay, there is 0, but if you will check the Ethernet priority is always 1. So you can see, let me show you here. So IP OSPF neighbor. Okay, see, Ethernet priority is always 1. So the priority is also there. Then it will be like dead timing, hello and dead timer. Then designated router. I will come to know what is the designated routers. Okay, later on. Do we have any designated router and backup designated router on this link? No, that's why it is 0. But if you will have any backup and designated router on this link, so you will have the information about that. And here is the neighbor information. So all these content will be there in the hello packet, and same thing is here. OSPF version, type, packet length, router ID of the sender, hello and dead interval. Okay, checksum error, area ID, DR BDR information, authentication type, data, subnet mask. Okay, area, stub area flag. So this is optional. We'll come to know what is the stub area. And then here active neighbor router information, like who is my neighbor. So here will be 2.2.2.2. And we have seen these all things here. Now in header we already came to know we have version, type, packet length, router ID, area ID, checksum, authentication type, authentication data. Okay, now we have already came to know what is this, like what is the use of version, type. Okay, version is different, like we are using OSPF version 2 or 3. So if I'm using IPv4 it will be version 2, and if I'm using IPv6 it will be version 3. Type means like OSPF packet type, same like opcode of EIGRP. So here in this type we have hello message. So hello message is type 1. So that's why we have here type 1. You can see type 1. Okay. Router ID, the router ID of the sender means what is the router ID of R1. Area ID, the both router belongs to which area, and it will be into this. Okay, like 0000 something like that. Checksum, it checks the packet header whether there is error or not. If there is no error, then it will move to another process. Authentication type. Okay, normally OSPF supports two type of authentication. One is plain text and one is MD5. Okay, so whatever type you are using, you will get the information there. And the authentication ID. Okay, type and ID. So ID, like what type of password you are using. Okay, okay, and data length. Okay, or means authentication type and data. Okay, so type and data is like the data what password you are using. Okay, and then there will be sequence number. Okay, so this OSPF neighbor condition we will be knowing in the our next lesson. that what is the condition to be same between the neighbors, so we can have neighborship. Okay. And okay, so no problem, so we'll check this one tomorrow, okay, or maybe in the next lesson.